Okay, our big idea today is on discriminants. What a discriminant is it's just a formula. It's this formula right here that's b squared minus 4ac. And what it does is it tells us the number of zeros or solutions or potential x-intercepts that we could have for a quadratic, that is. So this is for a quadratic, and it just tells us how many or the number of zeros or solutions that we have. And again, it doesn't tell us where they're at. It just tells us if they're real or if they're imaginary and how many there are in this case. So we have three options that we can get for a number. It's either going to be a positive number, a negative number, or zero. If it's a positive number, that means we have two zeros and they're both real, which means they're going to have x-intercepts. They're actually going to cross the x-axis. If it's negative, we have two imaginary zeros. So we'll have some complex number or imaginary solutions for our solutions or our zeros. Zeros, again, are another way to say as solutions to that quadratic. And then if it's zero, we have one real zero that's repeated. And so it has one x-intercept. So it does touch the x-axis and then bounce off. And we'll look at them graphically as well. So, all right, so really all you do is just take this formula, the b squared minus 4ac, and as long as it's in standard form, whatever's with the x squared term's a, whatever's with the x term is b, and then the constant is the c. And those, you just plug those variables in, those numbers in, and you go that route once you get it to that point. Okay, so we're going to look at a couple examples here. So this first one, in this upper left-hand corner, you do want to make sure that you are set equal to 0 here. It has to be that way. And then all I do is I say, okay, what is A? Well, there's A, there's B, and there's C, because the A term is always with the squared term, the B is always with the X term, and then the C is my constant. So I use my formula, this b squared minus 4ac, that's my discriminant formula. And then I simply just substitute things in for a, b, and c at that point in time. Whoops, don't forget to square this. So it would look like this. Again, b is going here, so I'm going to put 6 here. A is going here, so I'm going to put 3 there. And then 2 is going here. And then you can either do mental math or just use your calculator, whichever one you feel comfortable with at that point in time. So so this, again, if you use your calculator, we should get we should get 12 from that. Again, because this is going to be 36, and then we're going to go 12. So this would be 24 here, which would give you that. Okay? And so what that tells me is this is my discriminant. Okay? And so if I go back to this page, that 12 is a positive number, so I know there are two real solutions. So I'm going to put that there are two real solutions or zeros, whichever way you want to put that. And all that means is it's going to cross the x-axis at 2 spots. So there's 2 x-intercepts as well for that one. Okay? And that's all you're doing. Just plug in your formula, find your discriminant, and state what your, or how many zeros you are. Okay? If I look at this left one, I've got to make sure this is set equal to 0. So I have to add the 4 over first. And so then my equation becomes x squared minus 6x plus 4 equals 0. And now I've got my A, B, and C. So A is 1, B is -6, and C is 4. And so I can then go about plugging this into my discriminant formula here. So B goes here, so -6. A goes here, which is 1, and C goes here, which is 4. And then again, I just simplify. So I get 36 here, and then I get 16 here, which this is going to give me a positive 20. Again, if I have a positive number, again, there's my discriminant. If I have a positive number, that means there are two real zeros or solutions for that. And so that would be the other part that I'd want. Again, if you get a negative number, any negative number, there's two imaginary values. And if you get a 1, that means that there's one real. Okay. All right, look at one more example here down the lower corner. This one's just a little bit notation. If it tells you f of x equals, if it's just f of x, this is already in standard form. So my a is 1. Be careful here. There's no b. This is actually c. So b is going to be 0 because if there's not any, then I put a 0 for that. Okay, so a is -1, b is 0, and c is -4 from this. Okay, again, a is always with the squared term, b is with the x term, but there's none, so we put 0, and then c is your constant. So again, I just use my formula that I have. B goes here, which is 0. A goes here, which is -1, and then C goes here, which is -4. This will give me 0, and then I get -16, which that whole thing gives me -16. So there's my discriminant. Again, if I have a negative value, then that means there are two imaginary or solutions, I should say, or zeros, whichever way you want to put it. It doesn't matter. Okay, again, that all just goes back to this chart. Positives 2 reals, negatives 2 imaginaries, and zeros 1 real, and it's repetitive. Okay, so that's how we find our discriminant with a formula. If I look at a chart, all I want to know is what the sign of my discriminant is. And then I want to know how many solutions. So I want to know the solutions as well. Okay, so if I look at this first one, there are 2 places where it crosses the x-axis, so that means there has to be 2 real solutions or zeros. And if there are 2 real solutions, that means my discriminant has to be positive. So this would be a positive discriminant here. Okay. If I look at this left one, there are no x-intercepts. Okay, so that means that I'm going to have 2 imaginaries if there are no x-intercepts. Okay, and in that case, if there's 2 imaginary, that means that the sign of my discriminant has to be 0. Again, this would be the sign of my discriminant right here for this one. And then this last one, you can see it touches one spot right here. So that means that there is 1 real 0. And again, if there's 1 real solution, that means that, whoops, I am so sorry, guys. Hold on. You guys are probably thinking, hold up, Mr. Mumford. If there are 2 imaginary, that means that this has to be a negative sign. Okay, so the sign of my discriminant is negative on this one. If I go back down to here, if there's 1 real, then that means it's 0. Okay, so just to recap on a graph, if it crosses the x-axis twice, the sign of the discriminant is positive with 2 reals. If it doesn't cross at all, that means it's negative with 2 imaginaries. And if it crosses once, the sign of the discriminant is 0 with 1 real solution, or 0. So sorry about that little mess up. That's how that goes. And yeah, so that's your discriminant. Again, it's just a formula, and you just go that route. So should be good there, and yeah, rock and roll. This has been your Math Moment with Mummy. Adios.